Scientists from Vienna University of Technology, in collaboration with data storage specialist Cerabyte, have pushed the limits of miniature data encoding by carving a QR code that measures just 1.98 square micrometers, an area smaller than most bacterial cells. The pattern, invisible to the naked eye and undetectable with conventional optical microscopes, was created by directing a focused ion beam onto a thin ceramic coating, removing material pixel by pixel to form the familiar black and white squares of a QR code. Each pixel is only 40 nanometers across, roughly 1/10 of the wavelength of visible light, which explains why only an electron microscope can reveal the design. This achievement has been officially recorded in the Guinness World Records as the smallest functional QR code. Beyond the novelty, the work showcases a new approach to ultra-dense, long-term data storage. Traditional magnetic and solid-state media degrade over a few years and require continuous power to maintain integrity, whereas ceramic materials are chemically inert, thermally stable, and can preserve encoded information for centuries without any energy input. The researchers liken their method to the way ancient civilizations inscribed information on stone, ensuring survival across millennia. In theory, a single A4 sheet coated with the same ceramic film could hold more than 2 terabytes of data, far surpassing current storage densities. The team also emphasized the stability of the ceramic medium at the atomic level. While structures at the micrometer scale can suffer from atom migration that erodes data, the ceramic matrix locks atoms in place, making the code both readable and resilient over long periods. The process was validated under the watchful eyes of independent experts at the University of Vienna and confirmed using high-resolution scanning electron microscopy. Looking ahead, the researchers aim to scale the technique, explore faster writing methods, and experiment with alternative materials that could further increase density and reduce production costs. If successful, ceramic-based storage could become a viable solution for archiving critical scientific data, cultural heritage, or any information that must survive beyond the lifespan of conventional devices, while also reducing the energy footprint of massive data centers. The breakthrough represents a step towards truly permanent, energy-free digital archives, marrying nanofabrication precision with the timeless durability of ceramic science. The latest news you find here.